welcome everyone. Can you hear me okay? How's the level on this mic? Is that fine? Good, thank you. Oh, you're not on. All right, well, we'll get that. There's technical problems. We'll just have a moment here.
How about now?
Aha. He's live. Okay. Well, welcome everybody. Thank you so much for joining us. My name is McArleton, and this is Deva Racusin. And our other business partner, Ben Graham, who is running around right there, setting up the demo stages. And we are with New Frameworks Natural Building. We're based in Vermont. And we're here today to talk to you about this developing system that we're pretty excited about sharing with you all where we're heading and what we're trying to do. We wanted to start out just by giving a little bit of background why we decided to try to work on this project and develop it. Our story really begins as natural builders. The three of us were all very inspired by the use of natural, non-toxic, and local materials for our building systems. So we were very interested in using straw bale, earthen plasters, lime plasters, cob, wood chip clay, straw clay, and things of that nature. For their accessibility, the kind of joy that people have being able to get their hands onto that material. Often the materials are dug out of the land, right where the property is, of whatever structure is being built. Oftentimes it connects to local agriculture through the harvest of the straw. And then it's, I guess I would say, it's rumored high performance. that when we were first starting out, there was a lot of kind of blown out of proportion numbers in terms of the R value of straw bales. So many of us came into it saying, oh, this is this wonderful silver bullet. Why wouldn't anyone do this? It's so fabulous. And then for those of us, the three of us, rooted in the Northeast, which is both cold and wet, we really had a lot of, well, the number of times that we had to answer the question, isn't it going to rot, really led us to say, we need to do better and we need to know more. Many of these designs that people are using coming out of the Southwest, places like Arizona, Colorado, places that are much drier, even if they are cold, led us to really want to push the performance of the natural wall systems in this climate. So that's really a strong background of where we came from, wanting to pull heavily on the great work that some straw bale and natural builders have done. People like Bruce King, who've done amazing research into the engineering and design of straw bale buildings. David Eisenberg and the work of the National Building Network, the Environmental Building Network, EBN. And then our colleagues in the Northeast, we have a group of colleagues, we get together once a year, the Northeast Natural Building Network, NBNE, and mentors of ours, like Paul Lisinski, helped to really lead the way and set up straw bale building as a viable building assembly in the Northeast. So we're very indebted to their work and wanting to continue to build on that legacy of good design and high performance brought together with local, non-toxic, very hands-on, and quite literally earthy materials. So
the development of our practice in having these, these systems be tuned specifically for the Northeast, we compiled sort of a catalog of our practices in the context of doing this building into a book that was released in Chelsea Green last year, the Natural Building Companion. Through the development of that book, we realized that there was not a whole lot of really good, hard research and data to back up a lot of the performance of the systems that we had been promoting. So we undertook a pretty extensive series of performance tests and audits on a variety of different structures that we'd built, looking at moisture and thermal performance of these different buildings to basically proof of concept that these systems are working. And it was a terrific experience. We learned a whole lot about the materials and about these systems and how they're working, and came out of that experience realizing that what we're doing is great and we can take it even further, and there's even more potential for improving the potential of working with these materials and developing these systems. So that led us on this path of really working with a high performance high-performance building community. Ben and I getting trained through FIAS, the Passive House Institute US, to get a better sense of how high-performance design works in a new construction environment, working through Building Performance Institute to understand how building science works in existing structures, and really trying to apply that sort of core science physics principles to these materials to figure out how we can take things even further. And so from that marriage of high-performance design and construction and our roots in working with natural materials and natural systems, we're able to bring those together to essentially get the best of both worlds. And that's what's led us to the development of this system. So let's take a look at this system here.
Yeah, Ben, here, let's do the next slide. So we're calling this the StrawCell natural wall system. And so the super basics of it is it's a combination of straw bales with a 2x6 cavity dense packed with cellulose. And this is a photograph of the Schilling residence in Lisbon, Connecticut, which we worked on last summer. So this is a photograph from, gosh, I think it probably was June when this was taken. And so what you're seeing here is the framing on the exterior of the building. And so that is the structural stud wall that's supporting the roof and the rest of the structure that is then also dense packed with cellulose. And the bales then are laid to the interior of that plane, of that 2x4 wall, and then finished on the inside with plaster. And so we can get more into the details of that.
So the concept is we're looking for thermal bridge-free construction and foam-free installation solutions. So we're trying to be able to achieve, and we are being able to achieve all the comparable levels of both moisture durability and thermal performance without the reliance on materials that are quite as ecologically intensive and that are more accessible to a wider variety of people. So the cumulative R value of this wall system is approximately 50. We're getting about 30 from the bales. The framing, we have been using 2x6 stud wall construction. If you are working towards a passive house standard or some equally stringent standard of thermal performance, there are dials and knobs that can be turned around optimizing the insulation levels by changing the dimension of your framing. In this case, we have 2 inches of mineral wool insulation, insulated sheathing over the exterior of the frame, which is again another number that can be dialed in terms of upsizing or reducing that layer of insulation depending on the priorities of the design process.
Yeah, so let's actually start by looking at the exterior here. Hang on.
So for the far exterior, so on the far exterior face, we choose to use a cedar product that's milled locally in Vermont. In this instance, we have an over-vented rain screen, so there's a full drainage plane behind the cladding. And again, we have behind our strapping here the 2 inches of Racusin comfort board IS insulated sheathing, which again is an optional layer, but we've found to be really easy to employ to be able to boost the R value just that much further. The stud wall itself is dense packed. We are relying, because this is a non-structural sheathing product, we're relying on diagonal lead-in sheathing into the bracing into the stud wall itself. We favor the use of natively harvested and milled framing lumber, so we've been working with all rough dimensions. This is hemlock, yep, from MB Heath Mill in central Vermont. High performance windows. This is a sample that was generously donated to us by Linwood Windows, looking at full triple pane performance from our window system. And then moving to the interior.
So moving to the interior then, the characteristic thickness of the straw wall, which you know, is a liability for some and a benefit for others. We like to say it provides really great spots for sleeping cats and plants on the interior of your windowsill. So you can see that the window is set to the outside in terms of the profile of the wall, and that is because in a cold and wet climate, this is a part of the detailing that we've learned about as we've gotten more rooted in a cold and wet climate, is that unlike Arizona, where you could potentially put this to the inside and then have this lovely cool place to sit outside, we're much more concerned about the buildup of snow and rain. So this window is pushed all the way to the exterior there to protect all of the interior insulation. So then looking at the inside plane here, you can see the straw bales. Straw bales can be laid in multiple directions and dimensions. The basic size of them, they're 14 inches thick by 18 inches wide, and the length varies. Generally it's somewhere around 32 to 36 inches. So that can be resized. Actually, you can resize them in many ways. These have been put in vertically. We like to call it on end. So this is the end of the bale, so they're in vertically. And the orientation is an edge orientation, or 14-inch orientation. And so we can see the straps here. And essentially they're installed in such a way so that they fit tightly and nicely between the interior studs that are framing out the interior plane of the windows, essentially, of the window well. And then these two things that you see here are two different options that we use for attaching, essentially creating a washer system. These are what are called plate washers that we order online. And this is actually just a little chunk of plywood that you can cut on site and use as a washer. We pre-drill, and then these are 16-inch timber locks. So this is shooting all the way through that 14-inch bale and then sinking 2 inches in minimally to the framing on the other side. So this provides a really nice, really clean way of attachment to the structural frame. What else is interesting? Yes, the plaster, thank you. So we talked about the air barrier on the exterior. On the interior, the really important thing that we learned about straw bales is that they have to have a continuous air barrier. Now that's true with any insulation when you're going for a high performance system. Your air barrier is going to be one of the main things that's going to make or break the performance of your system. So for us, using straw bales, our air barrier is our plaster layer. That is what is the primary air barrier in the system. So what you see here set up for is we have a 5/8 gap between the framing, plane, and the backside of this trim, which allows for the space for a base coat of plaster. That is a mix that we create that is a combination of clay, sand, and chopped straw. Occasionally we'll add other things, lime potentially to stabilize it, and that is applied directly onto the bale. You do not need an additional mesh or any other kind of, primer or preparatory. Although occasionally we do spray just a clay slip, which is just a loose water mixture with clay, using a drywall texture gun and a compressor onto the bales just to kind of almost prime it, to create a clay layer that then that later coat will adhere to. And then what you see here on the bottom, on the wainscoting, is a lime plaster. And so this is lime mixed with sand, creating a durable and really beautiful finish, which will also go on top of the clay plaster on the interior. Oh yeah.
Hello? All right, so those are the basics of the system, the basic construction of the system. Let's talk about some of the benefits here. So we were able to achieve significantly higher insulative levels than just using straw bales alone. And that's actually been something of a limiting factor as we were looking at the potential of using our straw bale wall assemblies as we had built them, which would just be plaster on the other side of the bales, often with an interior timber frame. There was kind of a cap at about R30, R28 to R30, depending on what numbers you use, of what your insulative potential is for that wall system. That may not get you as far as you need to go, depending on the nature of your design and on the heat load, where the heat load calculations take you. So this gives us the opportunity to really crank up that installation to levels that we would need to be able to get to the most stringent potential of performance. What we also found is, we, rather than having a system that, again, prior to this, we were doing a lot of timber frames that are wrapped around with straw bales. That now has a couple of more...
Well, just to say, so the timbers would actually be on this interior plane, so you would see a giant, 8-inch by 8-inch timber on the interior, and that would be the structural frame for the building, and the straw bales would wrap around the exterior. That's another potential design, but as Jacob's saying, we found that there were quite a few liabilities in terms of cost and performance with that design.
So one of the benefits here is that rather than having to have a whole series of specialized trades involved in building out the shell of the structure, we're now able to bring the whole structural, bringing the structural and the exterior drying in sort of enclosure elements of the building envelope to be executed by more conventional trades. And so it does not require having to bring in specialty skills with finished plaster experience to be able to dry in your structure. You can have a much wider diversity of trades access, be able to put up a 2x6 wall, sheathe it, and put up paper. And then that gives a much more expanded window within which the more sensitive, climatically sensitive elements such as the straw can be brought into an enclosed envelope. So there's benefits both in the construction schedule and just in the ease of access of the system beyond having to have everything quite so hyper customized.
Okay, and our third benefit is airtight, which I sort of mentioned briefly, and many of us here at NESEA are pretty cognizant of why it is that an airtight construction is really important for performance. But for us, working with straw bales, that was something that, again, had never really been talked about in the straw bale community. People sort of said, oh, it's so wonderful, anybody can grab them, throw them up, plaster them, and you're good. And what we realized is that actually you need to do more than that. And so for us, it took us to a level, along with this research study that Jacob had mentioned that we did, where we tested 7 of the structures that we had built in New York State and Vermont. The thing that we saw contributed most clearly to any sort of losses through those wall assemblies were not any places where we had missed a transition from the wall to an edge of a window, or the wall to the top transition with the ceiling, or any of those spots. That was actually the most important part, because this solid sheet of plaster is a solid air barrier. There's no air getting through there. But as soon as that plaster ends up against something, you have a place that is a compromised edge, because there's going to be movement, there's going to be pulling away. So what we did was, using that thinking, to employ a series of gaskets and transitions at those edges, what we call an air fin, and that thinking has brought us to looking at this assembly and really finding a way to have a consistent airtight assembly on the exterior using the ProClima product, which we can spin and just show you guys. The exterior employs a more kind of, as Jake was saying, like traditional trades approach to air tightness. Here we have the flexible membrane, which is our air barrier, which is taped at all of the seams. And whereas on the other side, our air barrier, as we said, is our plaster. And then at every transition, there is an air fin, which is providing a gasketed, airtight kind of secondary support to that primary air barrier.
So again, owing to our roots as natural builders, what we've been really thrilled about is being able to integrate materials that are sourced very close to site from locally and regionally based industries that are practicing, in the case of wood, good silvicultural practices, and the use of straw, good agricultural practices, being able to tie our building systems into regional agricultural and food systems, being able to keep more of that money within the local economy, not having to import all of our products from faraway industries and from faraway resources, to be able to keep our values true to those priorities while not having to compromise on performance, and being able to maintain exceptional exceptional levels of moisture durability and thermal performance. So being able to prioritize the use of local wood and working with straw and finding a place for that within our wall systems was a high priority, and we've been really happy to be able to keep those values integral to the development of the system. Being able to come up with foam-free solutions has been particularly close to our heart. Not having to rely on the incredible embodied impact and toxic footprint of these materials, both before and after their intended use within the site, and some of the unintended consequences that come with moisture for the inappropriate use of some of these materials. We've been able to avoid that by, again, relying on some of the incredible technological benefits from the high-performance building industry, along with some of the natural and inherent value of working with these natural materials. And we feel really excited about that potential.
Yeah, and for us, a big part of that is bringing together, I hope you all are picking up the theme of bringing together kind of the natural and ancestral knowledge of natural building with high-performance technology and kind of evaluation of building systems. And so we think that we can bring those things together. What we've learned is that a clay plaster is an incredible air barrier that is both flexible, can be applied fairly easily by something they dug out of their backyard, and that provides an air barrier that is repairable, local, available, that is something that is democratic, that we have control over. So that's a part of that nature of what we're looking at in that system. Let's see. Oh, okay, great. Yeah, so super low embodied energy with higher performance. We talked about that. Give us the next slide, will you? Okay, great. So yeah, so this is our last slide. We put up basically just some detailed shots of the bottom of the wall connecting to foundation, and then the top of wall. Just wanted to open to questions. If folks have thoughts, ideas, questions, and I see a couple hands. Yeah, you want to go ahead?
So the way you have it now, if I wanted to hang like a heavy picture or shelving it all the way through that,
No. So the question is, if you wanted to hang heavy shelving or a picture, how would that work in a plastered straw bale house? Yeah, that is actually standard to any straw bale house, so that's not unique to this system. But the answer is, depending on how heavy it is, you could use a typical drywall anchor, which works most of the time just fine. If you're talking about shelving or cabinetry, that is something you have to anticipate for, and you either have to in nailers in the spots where you know it's going to go, or frame in front or something. Yeah, you do have to provide. You can't just screw cabinets into a straw bale. Yeah.
the same thing with electrical and plumbing and
So then the question is about electrical or plumbing. It's a great question. I mean, really trying to avoid running plumbing in exterior walls is always a good idea. But if you are going to run electrical, which we put outlets and switches on our exterior walls all the time, this baseboard can be expanded to be a chase, which is something that we've done, in a couple of projects to really great effect, which is really great. And then there's also a channel, which is hard to see, but you can see how my fingers are disappearing. We have a little channel behind this wainscoting transition, which can allow for a great chase for wires, and then you can bring them up and set a box right into the straw bale. You basically just notch it out using a chainsaw, create a groove, and then you can just pin the Romax directly into it. Depends a little bit on your local electrical codes, but for the most part, that's pretty standard.